In the previous video in aeromatics, we studied the turbulence flow in 2D pipe, which represents the most practical engineering applications. In this video, we will shift to the laminar flow system, where the fluid moves in smooth, parallel layers with minimal mixing. Laminar flow typically occurs at low Reynolds numbers, low velocity, small pipe diameters, or for high viscosity fluids. Using the same 2D pipe geometry, we will simulate laminar flow. See you in ANSYS workbench. Drag ANSYS fluent. Right-click on Geometry and choose Design Modeler. Look at XY plane. Zoom in till 1 meter to make it easy. Cylindrical body appears as rectangle from the side, so we'll work with rectangle. Drag it from the origin. Dimensions it will be 1.5 meter in length and 0.1 as radius. Remember, we are working on 1/2 of the pipe. To convert it to surface, choose Concept, Surface from Sketch. Now you can apply our sketch to it and generate. Click on our surface and change the material to be fluid. Now we can move for mesh. Double click on mesh. Select Z-axis. Insert mesh sizing. Choose edge selection. Select those edges. Change type to be the number of division. Set it to be 80. Change behavior to be hard. Insert mesh sizing again. Select inlet and outlet. Select type to be number of divisions. Set it to be 30. Change behavior to be hard. As it's laminar, we don't need to make a bias near to the wall. Insert phase meshing for the whole domain. And generate. Here is our mesh. Name our boundaries, centerline, wall, outlet, and inlet. Let's update our mesh and go for setup. Double precision. If you have a GPU, apply it to P1. If not, apply server processor according to your PC. From general, change 2D space to be axis symmetric. From models, select it to be laminar. Let's add a fluid. From Fluent database, choose water, copy and close. From cell zone condition, change fluid from air to your selected fluid. Apply and close. Boundary condition, the center line will be axis. Inlet, it will be velocity inlet. From reference value, compute it from inlet, and reference unit will be surface body. From method, choose simple and change all the variables to be second order. From monitors, change residual to be 10⁻⁻⁶. Finally, initialized. Standard and compute from inlet. After initialization, let's move on for calculations. Set number of iterations to be 500. Actually, it will end before this value. And finally, here is our residual. We can see the plot of velocity near to the wall and the center line. From plot, XY plot, choose Y-axis to be velocity, choose center line and plot. Now let's see near to the wall. Apply it, it will be 0. Save project and let's go for the post-processing. Select contour, location it will be periodic 1 shadow, variable to be velocity, and apply. We can make it more clear by changing it to be 100. As you can see, here is the behavior or flow in the pipe. Now we need to see the full pipe. Duplicate the contour, go for view, apply reflection for ZX plane. Let's make the same thing with the streamlines. Start with inlet. Duplicate to make reflection. There is something interesting there. We can make a small video with the streamlines. So choose animation, the clip item, select our streamlines, make it slow. That's all for today's episode. See you soon in another episode in Neuromaths.